Next, I will demonstrate the zonal statistics function in ArcGIS. Using the zonal statistics function, you can determine statistics such as mean, standard deviation, median, and so on within different zones. And the zones are usually a separate layer, either raster or vector, and the layer that you're going to do the statistics on is usually a raster. So in this example, we're going to look at statistics of the digital elevation model within the herd boundary displayed here, and we're going to look at the statistics within habitat and non-habitat. So the reclassified habitat layer that you created in earlier in this lab. And that's the NLCD class, where we have the pink areas are areas that are types like grass and shrubs that are used by the bighorn sheep, and the green areas are the areas that are less likely to be used. So start up the zonal statistics function. Again, spatial analyst tools. We're going to look at zonal and then zonal statistics, and we're going to do that as a table. And the input layer, my zones are going to be the reclassified habitats, so habitat and non-habitat. The zone field is going to be value, so that's going to be the 1 and the 0. And the input raster is the digital elevation model, because we're going to look at the mean, what's the mean elevation within habitat and non-habitat. And then you can give your output table a name, so we can call that habitat elevation statistics maybe, and save that, and then just go ahead and click OK. Alright, that runs pretty quickly, and here is the table showing up here at the, usually it ends up at the bottom of the table of contents. And you can open the output table, just right click and say open. And there it is. So we have for value 0, which was the non-vegetation habitat types, and 1 was the vegetation habitat types that are used by the sheep. You can see the different statistics. So you see the min and the max elevation within those two zones, the range, the mean. The mean elevation is apparently slightly higher in the areas not used by the bighorn sheep in this example. And standard deviation, sum, which wouldn't really mean very much in this case, variety, majority, minority, and median. So that's how zonal statistics works. Looks at one layer, a value layer, and it looks at the statistics for that value layer within zones of the zone layer. And let's go to the next section, looking at the tabulate areas function. I will show you how that works. You can use the tabulate areas function to cross-tabulate two different layers. For example, if you have identified habitat versus non-habitat, you could cross-tabulate that with an ownership layer and look at who owns or manages the habitat that you have identified. In this example, we're going to look at the land cover types by aspect. Earlier on, you reclassified an aspect layer in south and north facing aspects. 0 for north, 1 for south. And let's look at what land cover types occurs on south and north facing aspects in this area. So again, start up spatial analyst tools in our toolbox. This tool is located in zonal, and then go ahead and click on tabulate areas. So the input zone data is going to be my aspects 0 and 1 for north and south, and my land cover types. And we'll use the value. Again, we can look up these codes in a lookup table later. And it's always good to name your table. Land cover aspect, something that makes sense. And 30 meters cell size is what we have been using, so we'll continue with that and then click OK to have ArcGIS perform the analysis. Okay, that goes pretty quick, so let's open that table. And there's the output. So we have our north-facing and south-facing aspects, and then we have the area in square meters for each one of the land cover types, type 11, 21, 23, 31, and so on. So that's a very useful tool to cross-tabulate two data sets. The next section is section G in your lab document, and that's the combine command. Noticed how when we did the tabulate areas, the output was a table, but and you could look at how much area there was of each vegetation type on south and north facing aspects, but you did not get a spatial display. So if you want to display those things spatially, you need to use the command that's called combine in spatial analysis tools. So let's go ahead and demo the combine, and I'm going to demonstrate that by looking at the reclassified aspects, 0 for north, 1 for south, and cross-tabulate that or combine that with the land cover types, the classified ones that are classified into habitat and non-habitat, 0 for non-habitat and 1 for habitat. So the output layer will contain each unique combination of these 1 and 0s. Okay, the combine tool is located in Spatial Analyst Tools in Local. There's combine, and you just basically put the input raster layers in there. So, and you can cross-tabulate up to 20 different layers. So I'm going to cross-tabulate the classified aspects and the classified land cover types. And we'll give that a name, maybe aspect land cov. With these rasters, I think the limit is 13 characters for their names, so don't make them too long. So now we're going to create a new raster that shows the unique combinations of these two layers. And that finished pretty quickly, so here's our output layer, and if you open the table, as you expect, we have 4 unique combinations of the aspect classes and the reclassified NLCD classes. And you can also see how many pixels there are of each one of these unique combinations. For example, if we look at this row, the majority of the area is on the south-facing aspects within the NLCD types that are classified as habitat. So, and the good thing, or the, let's see, let's oh, I was going to clear the selected features there. So the good part about running the combine command is that you actually have a spatial layer. So if you, for example, would like to go and sample on these unique combination, maybe you want to set out sampling location and you want to have random points at each one of these unique types, you can do that, and I'll show you that in the next section here.